All right, so we're going to quickly review angles and then what's called coterminal angles. So first, how do I draw an angle? Well, if we start on our positive x-axis, which is the initial side, the terminal side is where this would stop. So we're going to always start here, and we're going to go counterclockwise. Now, this is 0 degrees. This would be 90 degrees. This would be 180 degrees. This is 270 degrees, and then this all the way around would be 360 degrees. So notice how from 0 to 360, their ending point would be the same. And that'd be true. We can go around multiple times. So if I wanted to graph something that was 120 degrees, I'm going to go through 90 and just about 30 degrees past. And so here would be my initial side and my terminal side. So that would be 120 degrees. Now notice too that we have these different quadrants. So we have 4 quadrants. We start in the positive axis here for x and y. In this quadrant 1, because we draw our angles going counterclockwise, also our quadrants go counterclockwise. So quadrant 1, 2, 3, and 4. So this angle 120, its terminal side ends in quadrant 2. So that might be a question that you are asked. One other thing that I want to touch on is we have this thing called coterminal angles. So if this angle is 120 degrees and you wanted to find one positive and one negative coterminal angle, meaning what angle will also land right at that same spot? What angle will start here and land at that same spot? Well, for example, what if I took this and went all the way around 360 degrees and then came back and landed at that same spot? So how you find coterminal angles mathematically is by taking your original angle, in this case 120, and adding 360 to it, because one time around a circle is 360 degrees. Well, 120 plus 360 is 480. And so meaning that 480 degrees is an angle that's called coterminal with 120. It's kind of like if you ever played any snowboarding or skateboarding video games, you know, and you do a 360, but then you do a 720. Well, you're still facing in the same direction. You just made more rotations. You just went around or spun around more than one time. I remember the big thing in skateboarding was to do a 900, or the big thing in snowboarding was to be able to do a 1080. So anyway, it's just how many rotations are you going. Now, what if I went the other way? What if instead of having this 120 and I added 360, what if I subtracted 360 degrees? Now that would give me a negative angle measure, and that would still be coterminal. So 120 minus 360 is a negative 240. Now, when we have negative angle measures, we still start at the same point, but now we go, okay, negative 90, negative 180, and then 60 more would be negative 240. So do you see how it doesn't matter if we have positive angle measures or negative angle measures, where they start and where they end would be the same. And so what's fascinating is that negative 240, 480, and 120 would be considered coterminal angles. Now, if that isn't confusing, a lot of times what gets a little more challenging is how do you find this stuff when you're dealing with radians? Degrees seems to make more sense because you're used to like protractors in science and other things in math, but in terms of radians, we don't use it as much, so it takes a little bit longer to get used to. Now, let's talk about radian measure. Remember, they're the same thing, just written in different form. So here's 0 pi radians, so 0 radians, so I'm still starting in the same spot. Here is pi over 2 radians. Here is pi radians. This is 3 pi over 2 radians. And this would be 2 pi radians. So, meaning just as one time all the way around the circle is 360 degrees, one time all the way around the circle is 2 pi radians. Now, if I wanted to graph this, a common mistake people make is they think one time around is 1 pi radian. So you just have to be very careful there. But if I want to graph 3 pi over 4, think of that as like 0.75. And so if this is 1, right, halfway around, if all the way around is 2 pi, halfway around would be 1 pi. Well, 3 pi over 4 is in between 1 pi and 1/2 pi, so I'm going to come here and I'm going to come all the way around halfway between, and I'm going to end in quadrant 2 again, a different angle measure than 120. This is really the equivalent of 135 degrees. But this is the angle measure 3 pi over 4. Okay, now we have coterminal angles with this as well. What if I wanted to take 3 pi over 4 and I wanted to add 360 degrees, right? We took our 120 and added 360 and we got 480. It's a little easier to deal with. But now instead of adding 360 degrees, I'm adding 1 revolution, which is 2 pi. And so yes, we actually have to figure out how to deal with fractions. And so 2 pi is not over, or is over 1. It doesn't have a common denominator like this one does. And so we have to figure out, okay, how do I write 2 pi over 4? In your calculator, or if you wanted to rewrite this as 8 pi over 4, so they have a common denominator, you would get 11 pi over 4, and that would already be simplified. So in your calculator, if you wanted to use that, plug in, ignore the pi, but plug in 3/4 plus 2, and then math, enter, enter. And when you did that, you should get 11 pi over 4. Don't forget to attach the pi there. Now what about the other way? What about a coterminal angle that is in the opposite direction, in the negative direction? So if I had 3 pi over 4, and I subtracted 2 pi, again, you can plug that in your calculator, 3 over 4 minus 2, math, enter, enter. But if I wanted a common denominator of 4, this would be 8 pi over 4. And so 3 minus 8 gives me that negative 5. So this becomes a negative 5 pi over 4. And so negative 5 pi over 4, 11 pi over 4 are all coterminal, one positive, one negative, of 3 pi over 4. You will get used to the radians the more practice you have, but initially, degrees tends to be a little bit easier. And so what we're saying with 11 pi over 4, we're saying, hey, we're going this entire revolution of 2 pi, and then we're going a little bit farther, and then boom, I still land in that same spot. Or negative 5 pi over 4, I'm going clockwise, but really, in the end, I'm still landing at that same spot. My starting point's the same, and my ending point's the same. How I got there just depends on how many revolutions total that I made.